In this problem, we are given that a squared plus b squared equals to 4,361. Given that a and b are positive integers, find the value of a plus b. So we are given that a squared and b squared have a sum of 4,361. We should try to get them in a similar form. And also use the property that a and b are positive integers. So we're going to express 4,361 as the sum of two perfect squares. To do this, I want to break down 4,361 into two perfect squares. So we can try to prime factorize it and see if we can use the prime factorized form of it and convert it into the sum of two perfect squares. So we can use short division to prime factorize this. What prime factors are divisible by 4,361? So 3 and 5 will not work because it does not satisfy the divisibility rules of 3 and 5. We can try 7. 4,361 divided by 7 will give us 623. Divide this by 7 again to give us 89, which is a prime number. So 4,361 equals to 7 squared times 89. So a squared plus b squared equals to 7 squared times 89. We already have 7 squared as a perfect square. We're going to convert 89 into perfect squares also to match the form on the left side. And we want to express this product as the sum of two numbers. This means that we want to express 89 as the sum of two numbers, such that if you expand the parentheses after turning 89 into the sum of two numbers, we can call as m plus n. So 7 squared times m plus n, such that m plus n equal to 89. After expanding, we want this to have the form of 7 squared m plus 7 squared n. Now we need to make sure that m and n are two perfect squares, so it can match the form of a squared plus b squared. We want to break down 89 into the sum of two perfect squares. Now, we can try the sum of perfect squares, and we can find out that 89 equals to 8 squared, which is 64, plus 25, which is 5 squared. So a squared plus b squared will equal to 7 squared times 8 squared plus 7 squared times 5 squared, which equals to 7 times 8, which is 56 squared plus 35 squared. The order does not matter for a and b because we're only trying to find the sum. So a plus b equals to 56 plus 35, which equals to 91. A and b can only be equal to 56 and 35 given the condition that a and b are positive integers. And for a recap, notice that we first started by prime factorization. 4,361's prime factorized form is 7 squared times 89. We did this so we can match the form of a squared plus b squared by manipulating the prime factors. But then we used an important property actually to determine if 89 can be expressed as a sum of two perfect squares. This is known as Fermat's theorem of sum of two perfect squares. It states that given an integer k is prime number if k is congruent, which means that if it's divided by a number, it will have a remainder of 1 when divided by 4. So it's congruent to 1 modulo 4. then k can be expressed in the form of a squared plus b squared. So using this, we can say that 89 can be expressed in the form of a squared plus b squared. And a squared and b squared in this case will equal to a squared plus 5 squared. Using that fact, we were able to find out the value of a squared plus b squared, and eventually find the value of a plus b. So that is how you solve this problem.